Welcome to the world of welding inspection. This training is provided by TWI Limited, based in Cambridge, UK, and covers essential knowledge and practices for ensuring weld quality and safety. This course covers a comprehensive range of topics, including duties of welding inspectors, welding imperfections, destructive and non-destructive testing, welding symbols, safety, and more. Welding inspectors play a crucial role in quality control, ensuring that welded items meet specified requirements. They must understand QC procedures, possess sound welding knowledge, and perform visual and non-destructive inspections. Visual inspection is a key non-destructive examination method. BSEN 970 provides requirements for personnel, inspection conditions, use of gauges, record keeping, and inspection timing. Welding inspectors should be familiar with relevant standards, welding procedures, and have good vision. Industry practice often requires practical experience and recognized qualifications such as CSWIP. Proper illumination and access are necessary for effective visual inspection. Tools such as gauges, magnifying lenses, and auxiliary lighting help inspectors identify imperfections accurately. Inspection is required before, during, and after welding, especially for high-integrity items. Each stage involves specific checks to ensure quality throughout the fabrication process. Inspectors refer to standards, quality plans, drawings, and QC procedures. They ensure inspection aids are in good condition and calibrated, and maintain detailed records for traceability. Safety is a responsibility for all employees. Welding inspectors must be aware of workplace safety regulations and ensure the availability and condition of safety equipment. Before welding, inspectors check materials, WPSs, equipment, consumables, and fit-ups. During welding, they monitor conditions, parameters, and welder qualifications. After welding, they verify weld identification, appearance, dimensions, NDT, repairs, and documentation. Inspection records vary by contract and fabrication type. When required, records must show checks at specified stages and include details such as manufacturer, item ID, material, joint type, process, acceptance criteria, imperfections, and inspector information. Understanding key terms is essential. Definitions include brazing, braze welding, joint, weld, and welding, as outlined in BS 499-1, 1991. Welded joints include butt, T, corner, edge, cruciform, and lap joints. Each type has a specific configuration and application in welding. Welds can be classified by configuration, fillet, butt, autogenous, slot, plug, and by penetration, full or partial. Joints can be homogeneous, heterogeneous, or dissimilar. Key features include parent metal, filler metal, weld metal, heat-affected zone, has, fusion line, weld face, root, toe, and excess weld metal. Understanding these is vital for inspection and quality. Weld preparation involves shaping component edges for welding. Types include open square butt, single, double V, single, W, single, double bevel, and single double J preparations, each with specific angles and features. Welding positions include flat, horizontal, vertical up, vertical down, overhead, and horizontal overhead. Techniques like weaving and stringer bead affect weld quality and appearance. Imperfections are deviations from the ideal weld. According to BSEN ISO 6521, they include cracks, cavities, solid inclusions, lack of fusion, penetration, imperfect shape, dimensions, and miscellaneous types. Cracks are serious imperfections due to local rupture. Types include longitudinal, transverse, radiating, crater, and branching cracks. They may occur in weld metal, has, or parent metal, and can be hot, cold, or lamellar tearing. Cavities such as gas pores, wormholes, and surface porosity are formed by entrapped gas during solidification. Causes include contamination, improper shielding, and welding parameters. Solid inclusions are foreign substances trapped in weld metal such as slag, flux, oxides, or tungsten. They can be prevented by proper cleaning, technique, and parameter control. Lack of fusion is the absence of union between weld metal and parent metal or between weld layers. Lack of penetration refers to incomplete melting through the joint. Both can compromise weld integrity. Shape and dimensional imperfections include undercut, excess weld metal, excess penetration, overlap, misalignment, angular distortion, incompletely filled groove, irregular width, root concavity, and burn-through. Other imperfections include stray arc, spatter, torn surface, grinding and chipping marks, underflushing, misalignment of opposite runs, and temper color. These can affect weld appearance and sometimes integrity. Acceptance standards define allowable imperfections. Cracks are generally not accepted. Unacceptable imperfections must be removed and repaired according to approved procedures, ensuring weld integrity. Destructive tests are used to verify mechanical properties and joint quality. They include tensile, impact, hardness, bend, and fracture tests, and are essential for welding procedure qualification. Transverse tensile tests measure joint strength, while all-weld tensile tests assess weld metal properties. Specimens are subjected to increasing force until fracture, and results are compared to standards. Cswip V-notch tests assess resistance to brittle fracture by measuring absorbed energy at various temperatures. Specimens are notched and subjected to impact loads, with results indicating material toughness. Hardness tests measure resistance to plastic deformation using Vickers, Rockwell, or Brinell methods. Hardness surveys are performed across weldments to ensure no region exceeds specified limits. CTOD tests measure fracture toughness by applying a load to a notched specimen and recording the crack tip opening. Results help engineers assess crack risks and make critical decisions. Bend tests verify ductility and soundness by bending specimens around a former. Fracture tests, including fillet and butt weld fractures, assess weld quality by examining fracture surfaces for imperfections.